So I'm going to be doing number 13 today. It says an actuary is studying the prevalence of 3 health risk factors denoted by A, B, and C. So A, B, and C. And before I continue, don't forget to check the description box for where you can find a copy of this and the solutions. Alright, so I like to write as I talk. For each of the 3 factors, the probability is 0.1 that a woman in the population has only this risk factor and no others. So why is it significant that they say only this risk factor and no others? I'll show you why. So we'll start with our little handy dandy little picture. And I'll let this be A, this will be B, and this will be C. So if you know much about this diagram, you know that A is composed of 1, 2, 3, 4. C, 1, 2, 3, 4. B, 1, 2, 3, 4. So when they say A only and no others, they want you to know that it's not A and B, it's not A, B, and C, it's not A and C, it is just this portion right here, not including those 3. And so there's a 0.1 probability that she's there, okay? Oh, for each of the 3. So for A, B, and C, just this one and no other, okay? For any 2 of the 3 factors, the probability is 0.12 that she has these 2 risk factors, but not the other. So once again, they're letting you know that this is A and B, but not C. It's A and C, but not B, or B and C, but not A. So that's denoted over here. And it's 0.12. Okay. I'm always dropping something. Alright. And the probability that a woman has all 3 risk factors given she has A and B is 1/3. Alright, so they say given. And when they say given, it's not right here. It's not 1/3 right here because there's a given portion to it. So, given probability that she has all 3, given she has A and B, equals 1/3. Okay? So what is this equal to? I'm trying to make sure the board doesn't fall. What is this equal to? This is equal to the probability she has A and B and C and A and B divided by the probability she has A and B. Alright, so what is A and B and C and A and B? So I'm going to call this X. A and B and C is this little thing right here, and A and B. What is inclusive of all of that? This is A and B. Okay, so we want the probability of A and B and C and A and B. What does that equal by looking at our graph? That is equal to, looks like X. Okay? Because we need C to be in there. So A and B and C is just right there. A and B and C and A and B, same thing as saying A, B, and C. Okay? So that's X. Now what is A and B? A and B is equal to what's here in this middle portion. Okay? They don't want A, B, and C only, they want A and B. So this part right here has A and B in it, and this part right here has A and B in it. So they didn't say only for this part, which is why we're able to do X plus 0.12 to signify A and B. Alright, so now we'll solve for x. We know that this right here is equal to 1/3. Okay? And I'm going to do cross multiplication, which would give me 3x is equal to x plus 0.12 minus x minus x. 2x is equal to 0.12, x is equal to 0.06. So all of that just to figure out that next portion. Alright? So now, what is the question asking? Calculate the probability. I'm going to erase some of this over here. Calculate the probability that a woman has none of the 3 factors, given that she does not have risk factor A. Okay? Probability she has none of the 3, given she has A. So our numerator is going to be these two combined, that she has none and she does not. And she doesn't have A. Divided by the probability that she doesn't have A. And I should have done this earlier, but I'll put the formula for given. Whenever you have given, A given B is equal to the probability of A and B. All of that divided by the probability of B. This is so helpful to know. You need to know that. Definitely need to know that. Golly. Alright, so she doesn't have any 3 and she doesn't have A. It's basically the same thing as saying she has none of the 3. So this part is just redundant. Divided by the probability that she doesn't have A. Okay? So let's figure out what none is first. To figure out what none is, none will be everything outside of the circle. So it's going to be 1 minus everything in the circle. I'm going to pull out my handy dandy calculator and I'm just going to go ahead and do this. My board has been falling so much. Probability of being inside of the circle is 0.72. 1 minus 0.72, we have 0.28 for her having none. Okay? And then the probability that she does not have A. Now, I didn't say the probability is she does not have A only. It just said A. So A is going to be inclusive of 1, 2, 3, and 4, which is equal to 1, everything that is not these 4 right here. So 1 minus 0.1 minus 0.12 minus 0.12 minus 0.06, which will leave us with 0.6 at the bottom. And we do 0.28 divided by 0.6, and we have 0.46667, which is approximately whatever they wrote here, answer choice C, 0.467.